To another segment of Terminating Low Voltage Cables. I'm Ron with IDEAL, and welcome to my shop and my channel. Hey, in this segment we're going to talk about cable TV splitters and give you some insights as to which ones you really ought to use, which ones you shouldn't use, and there are some out there that we do not recommend. So hang on, we're going to have a pretty good conversation here about cable splitters. And you know, I think it's kind of interesting when I see how people go out and buy these. Believe it or not, sometimes they buy it just based on pure color of the product, and you'll find that when you go out shopping for splitters, you'll find these gold kind of looking versions of it, and you'll normally find the silver looking color. Now, if I was making my decision based on color alone, which is probably not the brightest idea, if you take a guess at which one outsells the other, and if you guessed it was these gold ones, you'd be absolutely right. Color means absolutely nothing, and sometimes I see some interesting packaging out there where it looks like the manufacturer spent more money on the packaging than they did the splitter itself. And then the packaging will say something along the lines of it's ultra pro grade. Well, you know, there is no such thing as ultra pro grade. There are standards on splitters put out by the Society of Cable Telecommunication Engineers, and we want them to be compliant with this, but when you see things like that, that may not mean much to you. And then a lot of times we'll see some reference to gold plating of some sort on the splitters too on the packaging. I think that's kind of funny, because I know that's why the people buy so many of these gold ones, because they think they're gold plated. And believe me folks, if this was gold plated, it would be worth probably hundreds of dollars. The only time you have any plating here that means anything to you on a splitter is when I look down inside the opening here where the center conductor goes in. There's a little cam action thing that accepts that and makes the connection inside the splitter for us. But as far as anything else, nothing else is really plated that we really care. Again, not gold plated. And then also when I go out, and especially in like in a retail environment, we will find splitters that are what the marketing guy wants to give the customer that choice. We got that good, the better, the best kind of choice that the customer can use or take. And I'm going to tell you, as a general rule, the good ones, so to speak, are really no good, and they cause a lot of problems, and I'll talk more about that in a minute. The ones in the middle, a lot of times, are the ones we're looking for. They're recognized as being high performance, might say digital on them, or a lot of times they'll refer to a frequency range up to 1 gigahertz in frequency, and those are the ones you probably are looking to get. And then we find these, so to speak, super duper splitters that are usually a higher frequency rating on a splitter, but we may not really need it, especially for a cable TV application. So I'll go through all of these with you here in the next few minutes. And I'll start with the one on the bottom, which we really don't recommend anymore. And one of the interesting things about these is that you take the back off that splitter and you look down inside of what's in here, and it's not much more than a foil. These are, you know, fairly poorly shielded too. You'll find some black little, what we call ferrite cores that actually handle the splitting of the signal itself. Now, you got to understand something. This splitter was probably designed back in the 50s sometime. And back when everything in the world was analog only, no such thing as digital, and there's one strike against these. They really don't pass digital channels very well, if at all. And second problem with these splitters is they're not what we call bidirectional. And back in the day, there was no set-top box or pay-per-view kind of stuff. But today, you know, your cable modem, digital phone, high-speed internet, all these things have to communicate with the cable company. So all the devices in the system have to be bidirectional, including the splitters. So these are not bidirectional. So there's another reason if you take this thing home and hooked up your cable modem to it, and all of a sudden your high-speed internet's not working no more, a lot of you all will go out and call the cable company up and say, hey man, your stuff ain't working. When it was actually you that caused the problem. So be careful of these type of splitters. And so when we look at the high performance type splitters and above, the 1 gigahertz and above splitters, you open them up and you'll see a printed circuit board inside of these. And this actually handles the splitting of our signals for us. And again, it's good for analog and digital, and these are bidirectional, and those are the ones you're looking for. Now, another key factor when I look at a splitter, because I can be truthful with you, when you look at the outside of a splitter, you really cannot tell if it's any good or not. You almost have to look at the specifications and hope the manufacturer gave you something you can work with. Well, when you look at the front of these splitters, one other thing you'll see here is a reference to the frequency range of the splitters. Now, both the low-end versions and the more high-performance both have the same low-end number, and that number is 5 megahertz, okay? And that's the bottom of the frequency range in the cable TV systems. Now, the upper number has changed over years, and the reason is coax itself, RG6, has always been a pretty good sized pipeline, and all these wires in your houses are considered pipelines. And you know, back 30 years ago, we were only putting this much information down that big old pipe. But today we're stuffing this pipe like we never have, and so this frequency range has changed, the upper number. You know, 20, 30 years ago, it might have been a couple hundred megahertz in frequency up to, and then into the 500 megahertz range. And as we kept adding channels and channels and channels, we are pushing out to the upper end today, recommended by the cable industry, is 1,000 megahertz. Now, 1,000 megahertz, a fancy way of saying that is 1 gigahertz. So we want to have everything in the system capable of going out to 1 gig. And I want to tell you, most cable companies aren't going out that far yet. But there's a few. And, you know, may they go past 1 gigs in the future? Sometime they might. And if they do, we're going to have to replace all these splitters again. But at this point, this is the range that we're going to be recommending to you. Now, if you look at what other services use RG6 inside the building, typically that would be your satellite companies. And satellites operate at a totally different frequency within the building. They operate, and if you look at a satellite dish that collects a signal out of the sky, it's operating at a very high frequency over the air. But from there on in, there's coax going on into a satellite receiver in the home. So across that cable, the satellite system is operating in the home at between 950 megahertz in frequency, and it will go out to 2.15 gigahertz. And that's the frequency range of your satellite systems within your home. And if you take a piece of RG6, and if you look about every 2 foot, there's printing on it, and it tells you right on the printing what frequency range the cable's been tested out to, or it'll say swept to usually someplace between 2 and 3 gigahertz. And that's because we want that cable again to be used for both cable and satellite applications. And you know, could you mix the two on one piece of cable at one time? You could, because they are different frequencies. All right, so that is the frequency ranges that we're wanting to deal with. And you know, normally we would tell you don't split a satellite signal. Now, as a general rule in the past, we've never recommended splitters for satellite systems. We would use what they call multi-switches, a totally different thing. However, in the last couple of years, there's been satellite companies that are beginning to use equipment that can use splitters. So if you are going to attempt to split a satellite signal, first of all, I'd recommend you go talk to your satellite company, whether or not that's possible or not. It may not be possible, but if it is, you need to use a higher frequency splitter. Okay. Now, the only time I do recommend splitters on satellites, if you want applications where you'll see it used, is I could come off of the satellite dish on the outside of a home and bring wire on into a home, and it will go to the satellite receiver inside the house. Now you could come out of that satellite receiver, out of the output, and instead of going to a TV, you could go to, say, a splitter, and then feed maybe multiple TVs, if you'd like, with signal, okay? Now this does work. The downside of this is that all TVs are going to watch the same channel, which, you know, if you set up a restaurant or something like that, and that's what you wanted to see happen, would be okay. Now the question is, does it need to be a 1 or 2 gig? Because again, coming off the dish, it's operating in that 950 to a little over 2 gig in frequency range. But this 5 to 1 gig frequency range, if you look at TVs, for instance, they have tuners. They usually have a tuner that's somewhere under that range is designed to see. And over-the-air broadcast companies broadcast in that same frequency range. And actually, the AM and FM band is in that range too. So a lot of people use this frequency range, but the satellite receiver's got to drop it back down to what a TV tuner is designed to see, which is somewhere under 1 gig in frequency. So you could use a 1 gigahertz splitter here. Okay. So as you can see, as a general rule, I'm going to say in most applications we're going to use 1 gig splitters. We want them to be analog and digital in nature. We want them to also be bidirectional and compliant with the industry standards on splitters, and then they should work just fine for you. Now, going back to this frequency range and why we are so set on it. We start at the low end of 5 megahertz, as we mentioned. and the frequency range goes all the way out to 1,000 megahertz again, or again, that's a fancy way of saying that is 1 gigahertz in frequency. Now, it's interesting that this whole frequency range, your set-top box actually works very much like a radio does. The radio, you turn the knob and you want to go to another radio station, you have to tune to another, that's right, frequency. And when you go to 102.5, you hear a certain radio station, and 99 point whatever, you hear another one. So your TV, the remote, when I push the button on the remote and I want to go to, say, ESPN, the set-top box knows where ESPN has been programmed, what frequency. It goes to that frequency, basically pulls that information out of the cable and spits it out on channel 3 to your TV. So that's kind of basically how it works. And the way they've split up this frequency range, and this is what we call our bandwidth, our pipeline, our size of our pipe, all right? From 5 to about 55, maybe 54 megahertz, and I can't tell you exactly where, but somewhere they'll take a portion of the low end of this and they'll use that as what we call the return path in the system. Now, above that is going to be all video that we'll be using in our system, analog or digital. And back when everything was analog only in the cable TV industry, we needed a 6 megahertz window out of that pipe to basically get you one channel. So channel number 1 would sit between 54 and say 60 megahertz in frequency. And that's where channel number 1 would be sitting. And then we could put a second channel between 60 and 66. And that's again where channel number 2 will be sit. And in every 6 megahertz we got basically one more channel. And back when we were stopping at a few, maybe 100 and some channels, you take the frequency range of your system you're operating, say it's 800 and something, and you divide it by 6 megahertz, and that tells you how many channels you could have. In that case, that ended up being about 130 some channels we might be able to stuff in the pipe when everything was analog. Now, as you know, a lot of the world has gone to this digital signaling techniques that we have out there today, and it's interesting that we still use a 6 megahertz carrier wave, but in that wave we will digitize the signals. Now it's interesting, when I say digital, that does not necessarily mean high definition, but if it is a high def channel, we might be able to stuff 2, maybe 3 channels in that same 6 megahertz range if it's digital. And if it's a standard definition, they might stuff 8, 10, maybe 12 or more channels in that same frequency range. So that's how we're getting all these different channels in the cable TV world today, is going to this new digital techniques, okay? So, and again, as I said, most systems aren't going out to 1 gig yet, but it all depends on how many channels they're trying to give you. And eventually I think it'll all go digital somewhere down the road. Now, as I said earlier, when you look at the pipeline, and 30 years ago, again, we were using this much of that pipeline. So they had a choice, what portion of the pipeline would they put that video. And they could use the low end, they could use maybe a mid-range frequency at a couple hundred megahertz, or they could use these high frequencies. They had their choice, and the answer is they put them in the low end frequency range, in the low end down here. And the reason is because lower frequency channels, that signal, will travel further down the wire than the high frequency channels do. There's something in the cabling referred to as attenuation or signal loss in the cabling. And that loss is caused by 2 main factors. And one is the length of the wire. The longer the wire, the more loss you're going to have in it. And the second main reason is the frequency of the signal. And I'll give you a great example or an analogy here for you. If you ever take sitting at a red light sometime, and a car comes up behind you, and the guy's got the stereo just a blasting behind you, what do you actually hear? What sounds do you hear? And you actually hear the boom, 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 or the bass being generated out of that car behind you. And it's the same thing for signals traveling down wires. We really never wanted to put any channels way out here at the end, but you know what, we're being forced to because they got to stick them someplace. So this is why things have changed in the cable world, and we treat that wire a little differently than we did 20, 30 years ago, and we got to improve the connectors, we got to improve the splitters and everything else in order to make this system work like we want it to. Okay? So again, the higher frequency channels drop off so much faster for us. And as far as the 2 gigahertz splitters and above, again, they don't hurt you for the cable TV applications. May not really help you a whole lot, but they certainly don't hurt you. And thanks for coming to another segment of Terminating Low Voltage Cables. I'm Ron with IDEAL, and I hope that helped you with your splitter questions you had. Look forward to my next video on splitter loss and learn even more. See you later.